Welcome students for today's All Fours e-learning program and physics class. Yesterday we have discussed about different scales of temperature. The centigrade scale, Fahrenheit scale and Reamer scale we have studied. So to have a brief revision about that, brief review about that, for all the scales of temperature, if you observe the rise of levels in the mercury column, we generally take, let us suppose we are using different capillary tubes having this mercury here and placed in the same conditions. Suppose this represents the temperature in centigrade scale, this represents in Fahrenheit scale, and this represents in Reamer scale. Now, corresponding to the lowest temperature, we called it as lower fixed point. And lower fixed point, practically that is the, we said it is a melting point of ice. The melting point of ice is the lower fixed point. But now, in centigrade scale, we recorded it as 0 degrees centigrade. And Fahrenheit scale, we noted it as 32 degrees Fahrenheit, and in Reamer scale, again we have taken it as 0. Now, when the ice taken here, it is heated to water, and water is heated until it comes to the boiling point. Then, under the conditions of boiling water, the level of mercury, suppose it is seen here. That represents the upper fixed point. Remember, in all these three scales of temperature, lower fixed point is the melting point of ice, and upper fixed point, it is the boiling point of water. But now, in centigrade scale, this upper fixed point is taken as 100 degrees centigrade, whereas in Fahrenheit we have taken it as 212. And in Reamer scale, this is 80. So in all the cases, what we see is the level of mercury is expanding from the LFP, let us say the point A to the point B. This is the expansion in mercury level, whether it is centigrade scale or Fahrenheit scale or this Reamer scale. In all the cases, the expansion of mercury is same. But you can see it is divided from 0 to 100. We have divided this entire expansion of mercury into 100 parts. And here it is made into 180 parts. And here it is made into 80 parts. Therefore, the width of the degree, yesterday we have discussed about that. Width of the degree, because this total expansion from A to B, let us say it corresponds to a distance of x. Then the width of the degree is x by 100 here, and it is x by 180 here, and it is x by 80 here. Very clearly it is x by 100, x by 180, that means x by 80, which means that here the width of the degree is very high and width of the degree is least, because the same expansion is divided into 180 parts. Otherwise 100 degrees of centigrade corresponds to 180 degree in Fahrenheit scale. Otherwise, each degree centigrade corresponds to 180 by 100, otherwise 9 by 5 degrees Fahrenheit. That means when the temperature is increased by 1 degree centigrade, you can also express that as 9 by 5 degrees Fahrenheit. So, increase in temperature, when expressed in different scales, it will be different. Practically, the change in temperature magnitude is same, but when you express in centigrade scale, we say it is 1 degree centigrade, but when it is Fahrenheit scale, we are representing it as 9 by 5. So, in different scales, you will have the different values of the temperature. Suppose you are measuring the temperature of a body. When you are measuring the temperature of a body, I have kept this centigrade Celsius thermometer in that material. Now it shows some reading here. Let us say the temperature is some T. Now the same liquid, suppose it is this Fahrenheit thermometer is placed in the same material or same liquid, because the mercury is the temperature of the body is not changing. I am using the same liquid, but in the same liquid I am placing a centigrade thermometer or Celsius thermometer, and in the we are also placing the Fahrenheit thermometer, and we are also placing the Reamer thermometer in the same liquid framed at the same temperature. That means temperature that we are recording is the same. Temperature we are recording is the same, but the first thermometer gives the reading in Celsius scale or centigrade scale, the second one gives reading in Fahrenheit scale, and third one gives the reading in Reamer scale. But thing is, even though we are measuring the temperature of same body, as the scales are different, mercury will expand to the same level. Mercury will expand to the same level. In the first case, let us see the reading given is like this. This is the level of mercury in the first one, and so also in all the cases. But because different scales of thermometer have different divisions, width of the degree is not same. So even though the mercury expands to the same position, the temperature values are different. Let us say it is T1 in centigrade scale, and T2 in Fahrenheit scale, and T3 in Kelvin scale. Numerical values are different in the scales. Numerical values are different, but what you are measuring is the temperature of the same body. So as the scales are different, the value, the numerical value we obtain on the scale, it will be different. That means when you are measuring the temperature of same body, different thermometers, different scales which are graduated in different scales, they will give different readings. Then how to get a relation between these different scales of thermometers? So let us move on to get a relation between different scales. Suppose I am given the temperature of the body in centigrade scale. I want its value in Fahrenheit scale, or I want its value in Reamer scale. Then how to convert? So these conversions we can do from one scale of temperature to another scale of temperature basing on a fact, right? Let us go to that equation and let us discuss about that factor, right? Now, sometimes we will be dealing with a faulty thermometer also. Faulty thermometer means here we are giving about 3 scales. And you can devise or you can produce so many scales. But in any scale, if you consider, we are taking a lower fixed point and upper fixed point. Lower fixed point and upper fixed point. In all the scales we have studied, this is the melting point of ice and this is the boiling point of water. Let us fix those two for all the scales. But different scales of temperature, they give different readings for the same body, as we have seen now. Now, let us say the reading given by that scale of temperature is X. The reading given by a new scale I am creating now is X. Now, in this scale of temperature, let us calculate a factor L minus LFP, that is lower fixed point. This is the reading in the reading of the temperature of the body in that scale, and this is the scale reading minus LFP by UFP minus LFP. If you take this factor, it remains constant in any case of scale of temperature. Even in a faulty thermometer or in any new scale of temperature, or in our existing scales that we studied, centigrade, Fahrenheit, Reamer scale, in any scale of temperature, this factor always remains constant, where X is the reading of temperature of a body in a particular scale of temperature. So now let us apply this factor to all the different scales. Then how to get it? Now, suppose I am measuring the temperature of a body in centigrade scale. It gives a reading C degrees centigrade, and the same temperature I am recording by a Fahrenheit thermometer, which represents a reading, let us say F degrees, let me say Fahrenheit, and it is also measured by another Reamer scale which gives a reading R degrees, let us say Reamer. Then if you apply this principle, what is the principle here? X is the scale reading, LFP lower fixed point, so X minus LFP divided by this UFP minus LFP, difference between the upper and lower fixed points, this ratio will remain constant. Now if you apply this for these scales, we can use the relation centigrade scale is C minus, in centigrade scale what is the lower fixed point here? 0, and upper fixed point is 100 minus lower fixed point is again 0. So C minus 0 by 100 minus 0. That means, remember, we are measuring the temperature of the same body, but in centigrade scale the reading is C. Then C minus LFP by UFP minus LFP. C minus 0 by 100 minus 0. This is LFP, this is UFP in centigrade scale. That is will be equal to, because this factor is a constant in any scale of temperature. Now moving on to the Fahrenheit scale, reading given is F. So F minus, what is lower fixed point in Fahrenheit scale? It is 32 Fahrenheit, 32 degrees, divided by UFP. UFP is 212 minus LFP is again 32. That will be equal to, in Raymer scale, going to that, R is the scale reading given, and you know the LFP in Raymer scale is 0, and UFP minus LFP, UFP is 80 degrees minus 0. Then what you are getting here? C minus 0 by 100 minus 0. Let me write here. X minus LFP divided by UFP minus LFP. This is the factor we are discussing. In centigrade scale, what you are getting here? It is C by 100. That will be equal to here. It is F minus 32. 212 minus 32. It is 180, and that is also equal to R by 80 minus 0. This is 80. So this is a relation which we can use to convert the temperature from centigrade scale to Fahrenheit scale or any Raymer scale. In any way we can calculate. Now taking these three separately, what we can express? What we can express here is C by 100. That will be F minus 32 by 180. That is R by 80. So these are the relation between the three scales. Now taking here, we can cancel 20 in all these terms, which we can write like C by 5 equal to 9 by 5. Just a minute. C by 5 equal to F minus 32 divided by 9, and that is equal to R by 4. So finally we can use this relation to find out, to convert the temperature from one scale to another scale. So C by 5 is F minus 32 by 9, that is R by 4. Generally we are in problems, we come across the conversion from centigrade and Fahrenheit, because these are the most popular scales that we use. And of course we also be using Kelvin scale, and after this we will go for that. But if you consider the conversion very clearly, you will have, by cross multiplication you can write 9C by 5 equal to F minus 32. Otherwise directly you can use C will be equal to 5 by 9 and multiplied by F minus 32. So we can express the temperature in centigrade scale C equal to 5 by 9 of F minus 32, where F is the temperature recorded in Fahrenheit scale and C is the temperature recorded in centigrade scale. And similarly another relation to get the Fahrenheit also. So you can take this F value also. So now from this equation you will have F equal to, if I want the value of F, because this is F minus 32, take this 32. It is 9C by 5 plus 32, you can get the value of F also. So these conversions from centigrade to Fahrenheit or Fahrenheit to centigrade, most of the cases we come across like this. We can use these relations. Of course you can convert into Raymer scale also. So you can use the equivalence between these two. F minus 32 by 9 is R by 4 or C by 5 equal to R by 4. To convert from centigrade to Reamer or Fahrenheit to Reamer, we can take these two relations or this equivalence you can use. So most of the problems we come across the conversion from centigrade to Fahrenheit or Fahrenheit to centigrade, we can use these relations. Now we can also establish these relations in a different way. Sometimes it is also useful. Let us discuss that part also. That is, let me state one more important point here. Sometimes we may be given a faulty thermometer which is not correct, or a new scale of thermometer where the LFP and UFP are recorded in a different way, are taken in a different way. In such cases, suppose the faulty thermometer gives a reading X. It has its own LFP and UFP. But I want to express the reading given by that faulty thermometer into centigrade scale. Then you can use the relation, this part. That is, reading given by thermometer, faulty thermometer is X. And LFP and UFP are given here. So X minus LFP by UFP minus LFP. This part equate this to this one. It is C by 100. Then you equating these two. If you know the reading given by the faulty thermometer, you can calculate the value of temperature of that body in centigrade scale. Or if you want the temperature of the body recorded by a Fahrenheit thermometer, this factor you can equate to this factor F minus 32 by 100. Then you can get the value of the temperature in Fahrenheit scale also. Like this, from one scale to another scale, or we can convert. And another thing, if a faulty thermometer is given, the reading of the faulty thermometer, from that value you can find out its true value in centigrade scale or Fahrenheit scale using these relations. Like that, it helps us in conversions from one scale to another scale. Now, the same fact, the relation between these two scales, we can also express by drawing a graph. By drawing a graph between Fahrenheit scale and centigrade scale. Let us understand it like this. Suppose I take the temperature in centigrade scale on the x-axis and the temperature in Fahrenheit scale on the y-axis like this. Now suppose this is 0 on centigrade scale. The 0 on centigrade scale, that is the lower fixed point, that corresponds to the lower fixed point Fahrenheit scale is 32. So when the temperature on centigrade scale is 0, its value in Fahrenheit scale is 32. So the first point corresponding to centigrade scale value 0, in Fahrenheit scale it is 32. So 0, 32 is the first point you have to record. And now from this position, the temperature readings will be going on increasing, they are proportional. So if you take the different points, you will get a straight line like this. And finally, the corresponding to the upper fixed point, let us say this is upper fixed point. The upper fixed point is 212. And correspondingly, the upper fixed point in centigrade scale, if you record here, it will be 100. So this is 100 in centigrade scale and this is 212 in Fahrenheit scale. Now very clearly this width is 100, right? This width is 100. This is 0 and this is 100. And because this is 32 and this is 212, this is 32 and 212, the difference between these two, this is nothing but 180 values, 180 readings. So this part is 100, this part is 180. Very clearly the relation between centigrade scale and Fahrenheit scale you can know from this straight line. This is the straight line you are getting. Let us say this straight line is AB. And this straight line is having an intercept here, where you can express the equation of relation is y equal to mx plus c. This straight line is in this form, y equal to mx plus c, where y coordinate represents the Fahrenheit temperature and x coordinate represents the temperature in centigrade scale, where m is the slope here. So you can take the Fahrenheit reading as f equal to, what is the slope here? If you take the slope, let us say this is theta, tan theta is the slope. So the slope becomes tan theta, that is opposite side by adjacent side, that is nothing but 180 by 100 multiplied by the x coordinate is C. X coordinate temperature in centigrade scale plus the constant. The intercept is 32 here. So you will have the reading in Fahrenheit scale, that is 9 by 5 into C plus 32. We can establish like this also. So if you want, suppose the temperature is given in centigrade scale, we can convert into Fahrenheit scale by using this relation also. For example, temperature is recorded in is 5 degrees centigrade. I will take a numerical example. I am taking the temperature of a body recorded as 5 degrees centigrade. I want its value in Fahrenheit scale, let us suppose. To convert from centigrade scale to Fahrenheit scale, let us use this relation. In centigrade scale, the reading of the temperature is 5 degrees. To give in the values of Fahrenheit, let us use the relation F equal to 9 by 5 into the reading is centigrade scale. What is the value in centigrade scale? It is given 5 degrees centigrade. So this is 5 plus 32. Very clearly, it is 9 plus 32, 41 degrees. So when you measure the temperature of a body, its value is 5 in degree centigrade scale. But when you are expressing in Fahrenheit scale, it is 41. So clearly evident from this equation you can convert. Of course, we can also use the relation that we have written previously, that is C by 5 equal to F minus 32 by 9, and both are one and the same. You can use in any way. Both are one and the same. Only the thing is we have established in different ways. That's all. So you can convert from centigrade scale to Fahrenheit scale like this. So remember F equal to 9 by 5 into C, where C is the reading in centigrade scale and F is the reading in Fahrenheit scale. So F is 9 by 5 of C plus 32. We can establish like this. Now let us move on to some applications of this. Let us move on to some applications. Suppose temperature of a body is recorded as 45 degrees centigrade. 45 degrees centigrade is the temperature of a body recorded by centigrade thermometer or Celsius thermometer. I want the corresponding value in Fahrenheit scale. Then how to convert? So as we said, we can use any of the relations. That is F equal to, we have taken 9 by 5 of C plus 32. Right? Let us convert here. So the reading given in the Fahrenheit scale, that is 9 by 5 times 9 by 5 of the value in centigrade scale. We are getting it is 45. So it is 45 plus 32. What you are getting here? 5 times here, 5 into 9. It is 45 plus 32. Then it becomes 77 degrees Fahrenheit. So when you read the temperature of the body with a Celsius thermometer or centigrade thermometer, it is 45 degrees centigrade. But when you are using a Fahrenheit scale thermometer, the reading given by it is 77 as per this conversion. So like this we can convert from one scale to another scale. Unlike this, suppose the temperature of a body is recorded as let us say 90 degrees Celsius, 90 degrees Celsius, 90 degrees centigrade. I want the corresponding value in Fahrenheit scale. How to get the value in Fahrenheit scale? Now here we are giving the value of C. So I want the value in Fahrenheit. So another example like this. So let us convert. So use the same relation. So F equal to 9 by 5 and his temperature is centigrade scale is 90 plus 32. So you can find out. So this is 9 into, it is cancelled, 19 times, right, 18 times plus 32, right, we can calculate, right. So we can convert the values from one scale to another scale like this, right. And final answer here is 9 into 18, right, 90 plus 72, 162 plus 32, you can write the answer, it is 194. So you are getting the value like this. So when it is recorded as 90 degrees centigrade, you are getting the value in Fahrenheit scale like this. So this is one type of conversion. Now let us make a conversion in the reverse direction. Let us take a value in Fahrenheit scale and let us try to establish in centigrade scale. Now let us go for that. The reading in Fahrenheit scale, that is given as, from the given equation, 9 by 5 times the centigrade reading plus 32. Now let us take the value of C here. So 9 by 5 of the centigrade thermometer reading, that is F minus 32. Otherwise you will have the value of C is 5 by 9 of F minus 32. We can use this relation to find out. For example, I have taken the temperature of a body recorded by a Fahrenheit thermometer as 52 degrees Fahrenheit. We have recorded like this. What the value of the temperature of the body when recorded in centigrade scale? So let us convert. So C equal to, it is 5 by 9 of F minus 32. The reading given in is 52 degrees. So 52 minus 32, it becomes 5 by 9 of 20. Otherwise it is 100 by 9. So we can find out. It is 11.11 like this. You will get an answer. So when it is recorded as 52 in Fahrenheit, correspondingly it is 5 by 9 of F minus 32. F is 52. So it is 52 minus 32 of 5 by 9, or it is 100 by 9. Right. So you will get an answer like this. So you can convert from using this formula from one temperature scale to another temperature scale. Right. Now let us move on for the conversions of changes in temperature. Changes in temperature. We have given that C by 5, the relation between the different scales as C by 5 as F minus 32 by 9, that is R by 4. Now if you consider changes, here so far we have calculated the value of a temperature from centigrade scale, and then we have taken the value, corresponding value in Fahrenheit scale. And similarly we have taken a reading given in Fahrenheit scale and we have established its value in centigrade scale. Now let us take the changes. Suppose the temperature of a body is changed by 10 degrees centigrade. Temperature of a body changed by 10 degrees centigrade. Then what will be the corresponding change in Fahrenheit scale? So those changes, we can use this relation as delta C by 5 from this equation. That will be equal to delta F by 9. That will be equal to delta R by 4. You can use this relation to find out the corresponding changes. Delta C by 5 will be equal to delta F by 9, that is delta R by 4. By differentiating this, you will get these relations. And now suppose the temperature of a body is changed by 10 degrees centigrade. Then what will be the corresponding change of the temperature of the body when you give in Fahrenheit scale? That is in Fahrenheit scale, that is delta F. Let us find out. So delta F as per this scale is delta C by 5. Delta C is 10. So by 5 that will be equal to delta F by 9, which is very clearly delta F equal to, by cross multiplication, it becomes 18 degrees Fahrenheit. That means a change of temperature equal to 10 degrees centigrade change is numerically equal to 18 degrees centigrade, 18 degrees change in Fahrenheit scale. So 10 degrees centigrade change is equal in centigrade scale is equal to 18 degrees change in Fahrenheit scale. We can convert from one scale to another scale like this. So when you are considering the changes, remember this relation will help us. Delta C by 5 is delta F by 9, that is delta R by 4. Suppose this centigrade change is 10 degrees centigrade. I want the corresponding change in Reamer scale. Let us apply this equation. So delta C by 5, that will be equal to delta R by 4. If you take the values, delta C, the change in temperature of the body in centigrade scale is 10. So it is 10 by 5, that will be equal to delta R by 4. very clearly change in temperature in Reamer scale. Delta R is 4 into 2, 8 degrees in Reamer scale. So we can convert the changes also from one scale to another scale like this. So these conversions, remember when you are using the value of temperature in one scale to convert into another scale, we can use this relation. If you want the changes to be converted from one scale to another scale, we can use this relation for changes. This gives the relation between the values of temperature, and this gives the relation between changes of temperature. These are the two examples, two equations that we can use while solving the numericals. Right? This class, let us stop here. In the next class, we will come across, we will discuss about some more numericals and some other relations also. So let us stop here.